Every aspect of our existence requires electricity. We just can't survive without it. It would be impossible to go without fans and air conditioning for even a short period during the summer. All of them run on electricity. Without electricity, institutions, including government buildings, courts, banks, industries, and hospitals would shut down immediately. But there are some widespread misunderstandings about this electricity. These are common misconceptions even among experts who should know better about electricity. Some of these misconceptions and how to solve them will be discussed today. Whenever there is an electrical fault in the house, we get a 220-volt shock. All of us share this fundamental misconception. In reality, we're shocked by 311 volts of electricity rather than the more common 220. That's true, right? How? The 220 volts shown by our home equipment is the RMS voltage. To put it simply, animals are shocked by the AC voltage when it peaks. What is the root mean squared value? When the heat output of an AC source is about the same as that of a DC source, we say that the AC source's RMS value is comparable to DC's. The relationship between the root mean square and the peak value is Vrms equals V0 by root 2. So, the peak value equals V0 equals 220x root 2 equals 311.124 volt. This means that in the event of a house fire, we would be exposed to 311 volts of electricity. This is the highest possible point. Once again, the AC volt peak-to-peak value is 622 volts. When the light is turned off, no electricity is produced. The idea is flawed. There is still electricity present even after the switch has been turned off. This explains why there is still a faint glow from the bulb after the power has been cut. Energy may be stored in the inductive, capacitive load for a relatively short period. Do only animals experience pain from electric shocks? The common belief is that only animals can be shocked by electricity. They also believe this to be the case since birds do not experience an electric shock from the cables. However, the truth is far different. Electrical current will flow through any animal that can complete a circuit. Most electrical currents may be safely conducted through rubber and wood. Electrical engineering students would do well to remember that an insulator is not always an insulator. Exceeding the breakdown strength causes the insulator to take on the role of a conductor. Is water a poor electrical conductor? It is a commonly held belief that electricity cannot travel through liquids like water. There is some truth to this idea. Electrons are not able to flow through pure water. Water is a good conductor of electricity by itself, but when other chemicals are added to it, such as an acid or a base, it stops conducting electricity. Does the power still flow through a phone after it is completely charged? In a sense, this idea is both correct and incorrect. This is conditional upon how the mobile phone is charged. What will happen with the flying mode is engaged when charging? After the phone has been completely charged, electricity stops flowing through the cable and it stops charging. Electricity can only travel from one end of a wire to the other if there is a potential difference between those ends. Here, however, there is no voltage between the source and the load. Because both the charger's rectifier and the battery have a voltage of 4 volts, what happens when charging and the electricity, Wi-Fi, and data are all on? If this is the case, then even after the charger has been filled, energy will continue to flow through it. The voltage gap persists since the data, Wi-Fi, and power all use battery life constantly. This means that the charger continues to draw power even after it has been completely charged. What is meant by a neutral state in this case? The departure point from the neutral state is the location where the current is zero. A circuit is incomplete without a neutral. Once again, this is the point when the current loops back on itself. Why is earthing done? A gadget may be safeguarded by earthing. With the aid of the earth, any surge current in the circuit may safely escape to the ground. The earthing cable functions as a short circuit in this application. Thus, the neutral conductor is the return channel for the load current while the earth conductor is the return path for the surge current. Together, neutral and earthing bodies may be around for a while. To prevent an overload, neutral points at substations are often earthed. The earthing and neutral wires of 2-pin connectors are combined into a single cable. A 3-pin plugs neutral and earthing are combined into a single cable. Does a neutral point have any voltage? There is no truth to this at all. Still, there is some voltage present. Scientists began utilizing zero as a reference point for their environment. Why is this happening, exactly? What steps would you take if you were tasked with determining the voltage at a specific location inside a circuit? Obviously, you will choose one real point and another as the reference point. The voltmeter is then held midway between the two locations. A zero voltage reference point simplifies the estimation of the true voltage. So, let's clarify things. To explain, let's imagine that the average height of a mountain range is 500 feet above sea level. The sea level is at its lowest point here, although the depth of the ocean is considerable. The real voltage from phase to neutral is simple to determine in this case. Therefore, it may be zero in theory but is not in practice. How will the current flow back if there is no voltage pressure? This flow of energy has now returned to its beginning. When ocean water evaporates, it follows the same path as precipitation, eventually draining back into the ocean. We expect that now you have a clear idea of what electricity is and how it works. We are sure after reading all the misconceptions we mentioned, you'll be able to make accurate decisions about how much of your electricity consumption can be saved by switching some of your appliances for new models. For more informational content, don't forget to like, share, and subscribe to our channel, Explified.